Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 2.4, Problem 7. This is Section 2.4, Problem 7. It says multiply the matrices, and you actually have 3 matrices, and there's some parentheses grouped around 2 of them. Now, if you notice, this is the same problem as number 6, except the parentheses were in a different spot. So if you look at number 6, you'll see if we wind up with the same answer or not. Let's see what happens. So in any type of math, you need to do the work in parentheses first. So for now, I'm going to just simply ignore the matrix that's outside of the parentheses. Inside the parentheses, there are 2 matrices to multiply. The first one has 1, -2 on the top row, and then 2, -1 on the bottom row. And it's multiplied times a small matrix, just 1 column, 3 in the top position, 1 in the second position. So we'll focus on that first, get an answer for that, and then once we get an answer, we'll take the matrix outside of the parentheses into account, only after we've completed the work in the parentheses. So within the parentheses, first we want to see if there is in fact even a solution. So to do that, you want to check to see if the number of columns in the first matrix is equal to the number of rows in the second matrix. And again, the easiest way to do that is just write the dimensions underneath each matrix. So the first matrix has the dimensions 2 by 2 because it has 2 rows and 2 columns. And the second matrix is a 2 by 1 matrix because it has 2 rows and 1 column. And now when you look at the inner numbers of the dimensions, the inner numbers do match. They're both 2. So there is a solution, and the solution will have the dimensions 2 by 1 left by the outer numbers of the dimensions written underneath. So it'll have the same format as that second or right-hand matrix with 3 on top and 1 on the bottom. So let me write that underneath, again keeping in mind that once I get the answer, I'm going to try and multiply it times the matrix that's outside of the parentheses. So if my answer inside the parentheses is a 2 by 1, it'll have 2 rows and 1 column, which I will write with big boxes that I'll write the work inside the boxes, and then afterwards just write the answers. So I need to multiply each row of the first matrix times the column I have in the second matrix and do that work out. So I'm going to start with the top row of the first matrix of 1, -2 times the only column of 3, 1 in the second matrix. So when I do that, first times first, 1 times 3, plus second times second, which is -2 times 1. And when you do the work, first times first, 1 times 3 is 3, and second times second, -2 times 1 is -2. So 3 plus a -2, or just simply 3 minus 2, we get an answer of 1. And it went in that spot because I multiplied the top row of the first matrix times the only column of the second matrix. So we put our answer in the top row and only column there is. And now the next box I'm going to fill in by multiplying the bottom row of the first matrix, 2, -1, times the only column of the second matrix, 3, 1. So first times first is 2 times 3, plus second times second is -1 times 1. So first times first, 2 times 3 is 6, plus second times second, -1 times +1 is -1. 6 plus a -1, or 6 minus 1, will be 5. So we have an answer. So our work in the parentheses is done. So now I'm going to take the matrix that was outside of the parentheses and multiply it times the result we got from the work inside the parentheses. And now that problem becomes the matrix from outside the parentheses had 2, 1 in the top row, -3, -6 in the middle row, and 4, 0 in the bottom row. And I'm going to multiply that times the result of the work in parentheses, which is a matrix with only 1 column, a 1 in the top position and a 5 in the lower position. And I want to multiply those 2 together. So first, you need to see if there even is an answer for this. And again, what we want to see is if the number of columns in the first matrix is equal to the number of rows in the second matrix. The way to check that is to write the dimensions under each matrix and see if the inner numbers of your dimensions match. So the first matrix has the dimensions 3 by 2 because it has 3 rows and 2 columns. And the second matrix has the dimensions 2 by 1 because it has 2 rows and 1 column. And when you write that out, the inner numbers do match. They're both 2. So there is a solution, and the size or dimension of the solution is given by the outer numbers of the dimensions written underneath, 3 and 1. So your answer will be a 3 by 1. It'll have 3 rows and 1 column. So let me write that out. Again, I'll write the big boxes that I'll do all my work in first. And I'll set up boxes in the format of having 3 rows and 1 column. And as I start filling that in, I'm going to multiply the top row of the first matrix, 2, 1, times the only column of the second matrix, 1, 5. So first times first is 2 times 1. Plus second times second is 1 times 5. And when you do first times first, 2 times 1, you get 2. And then second times second, 1 times 5 is 5. And then 2 plus 5 more is 7. And I put that answer of 7 in the spot I did. I multiplied the top row of the first matrix times the only column of the second matrix, and I put my answer to that in the top row and only column of my solution. And now, the next thing I'll do is multiply the middle row of the first matrix, -3, -6, times the only column of the second matrix, 1, 5. So first times first, -3 times 1, plus second times second will be -6 times 5. So -3 times 1 for the first times first is -3. And then second times second, -6 times 5 is going to be -30. So -3 plus -30 is -33. And then finally, and again, the answer I got went in a particular spot. I multiplied the middle row of the first matrix times the only column of the second matrix, and my answer went in the middle row and only column of the solution. And now finally, the bottom row of the first matrix, 4, 0, times the only column of the second matrix, 1, 5. So first times first is 4 times 1. And then second times second is 0 times 5. And now first times first, 4 times 1 is 4. And second times second, 0 times 5 is 0. And 4 plus 0 is 4. So now, the final answer, this is the answer, but it's best not to write it with all the work. You'd have one matrix with 1 column. The top value in that 1 column is 7. The middle value of that 1 column is -33. And the bottom value of that 1 column is 4. And that's the answer for number 7.